What's up everyone, it's Stack Lessons here. Welcome back to the channel. Today we're diving into practice exam walkthrough, 20 scenario questions with deep analysis. Let's get into it. By the end of this video, you'll have a repeatable method for answering scenario questions on the Amazon Web Services Certified Data Engineer Associate exam. We'll walk through 20 realistic questions, weighted across all 4 domains, and for each one I'll show you how to eliminate the wrong answers before choosing the right one. The method matters more than any single question, because it's what you'll use on exam day when the scenario you see is one you've never practiced. Here's the thing that catches most candidates off guard. On a well-written scenario question, 2 of the 4 answers will technically solve the problem. Both will use real Amazon Web services in valid ways. Only one of them fits the specific qualifier in the question stem, and that's the one that scores. The skill we're building today isn't memorization. It's learning to spot which detail in the scenario disqualifies the answer that sounds right but isn't. The elimination method has 4 steps and they go in order. Step 1, read the last sentence of the stem first. That's where the verb lives: choose, configure, design, and that's where the qualifier hides. Step 2, form your own mental answer before you look at the 4 options. This prevents the distractors from planting doubt. Step 3, eliminate any option that violates the qualifier, even if that option would technically work. And step 4, among the survivors, prefer the most Amazon Web Services native lowest overhead choice. That's the whole loop. Here's that loop visually. First, read the last sentence to find the verb and the qualifier. Next, identify which specific phrase is doing the work: least overhead, sub-second, minimal code changes. Then eliminate every option that violates that phrase, even if the option would solve the underlying problem. Finally, pick the most Amazon Web Services native survivor. You'll run this loop 20 times in this video, and roughly 65 times on exam day. Think of yourself as a detective in a locked room mystery. You don't start by guessing the killer. You start by ruling out the suspects who couldn't possibly have done it. By the time you've eliminated 3 of the 4, the 4th wins by default. Same thing here. Even when you don't know the right answer with certainty, eliminating 2 of the 4 options doubles your odds from 25% to 50%. Elimination is mathematically powerful, even when you feel unsure. Amazon Web Services says this directly in its own certification guidance. The distractors aren't just wrong answers, they're plausible options that don't actually answer the specific question being asked. That's the key phrase. Don't answer the specific question. A distractor is usually a valid service used in the wrong scenario, or the right service applied with more operational overhead than the qualifier allows. Once you see them as deliberately constructed, they stop feeling like traps and start feeling like clues. Quick word on time management before we start. Budget 2 minutes per question on the first pass and treat that as a hard limit. If a question pulls you past 2 minutes, flag it and move on. Later questions sometimes hand you the answer to an earlier one. A service name in question 40 might unlock the right answer for flagged question 12. And critically, never leave a question blank when you submit. There's no penalty for guessing, so lock in your best elimination-based answer before you flag. Think of it like a buffet on a time limit. Don't stand at the first dish trying to perfect your plate. Circle the entire table first, grab everything you know you want, and come back to the tricky dishes at the end. The same applies here. Bank the easy questions early, then use your remaining time on the hard ones. Spending 8 minutes on question 3 means 4 other questions get rushed at the end. And here's something worth internalizing before we begin. Amazon Web Services uses compensatory scoring, which means you don't need to pass each domain individually. You only need to pass the overall exam. So if one domain feels brutal on exam day, don't panic, bank every easy point you can across the others. There is no minimum per domain score you have to hit. The 20 questions are weighted to match the real exam distribution. Domain 1, Ingestion and Transformation, gets 7 questions, the largest share. Domain 2, Store and Manage Data, gets 5. Domain 3, Operate and Support, gets 4. And Domain 4, Security and Governance, also gets 4. That ratio mirrors what you'll see on exam day, so practicing in this distribution builds the right muscle memory. Let's start with Domain 1. 7 questions focused on ingestion and transformation. The services you'll see most are Glue, Kinesis, the orchestration trio of step functions, Glue workflows, and MWAA, plus format conversion patterns. Watch how the qualifiers shift the answer between services that all technically work. Question 1. A retailer receives a daily partner CSV file. Some days the file is empty. The team needs to fail the pipeline whenever an empty or malformed file arrives, and they want the least operational overhead. Your options are A. A custom Lambda checker, B. Step functions branching, C. Glue data quality with DQDL, or D. Athena CTAS validation. The qualifier here is least operational overhead. Take a moment to think before I walk through the elimination. Let's eliminate. The Lambda checker means writing custom code to read the file, count rows, and decide whether to fail. That's the opposite of least overhead. B. Step functions branching adds an entire orchestration layer for a single validation check, overkill. D. Athena CTAS is a query engine, not a validation tool. That leaves C. Glue data quality with DQDL. The rules live right inside the existing Glue job. Completeness and freshness are built-in rule types, and there's no extra service to manage. C is the answer. Question 2. Payment events must be scored for fraud in under 1 second end-to-end. Each event needs custom Python logic before scoring. Which ingestion and processing pair fits? A. Firehose to S3 to Athena. B. Kinesis data streams to Lambda. C. Firehose with a Lambda transform. Or D. SQS to a Glue job. The qualifier is sub-second. Pause and think about which options that single phrase eliminates. Sub-second eliminates anything that buffers to S3. O is out. Firehose delivering to S3 has a 60-second minimum buffer. C is out for the same reason. Even with a Lambda transform, Firehose still batches before landing in S3. D is out because Glue jobs take minutes just to start up. That leaves B. Kinesis data streams to Lambda. Streams delivers records in milliseconds. Lambda runs your custom Python on every record, and this is the standard real-time scoring pattern. The cue here is simple. When the requirement says sub-second end-to-end processing, eliminate Firehose immediately, it buffers, and buffering kills sub-second guarantees. Question 3. A team has 40 production Airflow DEA-C01 running on-prem. They want to move to Amazon Web Services with minimal code changes. Which orchestrator fits? A. Step functions, B. Glue workflows, C. MWAA, or D. Event bridge scheduler. The qualifier is minimal code changes. Hold that phrase in mind as you eliminate. Step functions would mean rewriting all 40 DEA-Cs in Amazon State's language. That's a lot of code changes, eliminated. B. Glue workflows only orchestrates Glue jobs. It can't run an Airflow DEA-C at all. D. Event bridge scheduler just fires events on a schedule. It isn't an orchestrator. That leaves C. MWAA, which runs your existing Airflow DEA-Cs unchanged. Minimal code changes is the MWA, a trigger phrase. Notice the subtlety. If the qualifier had been least operational overhead, step functions would often win. Here it's portability, and MWAA owns that lane. Question 4. 5 terabytes per day of JSON logs land in S3. Analysts query with Athena and the bills are out of control. The team needs the cheapest ongoing conversion to columnar format. An EMR Spark job nightly. B. A Glue ETL job nightly. C. Firehose record format conversion. Or D. Athena CTAS daily. 2 qualifiers, cheapest and ongoing. Think before the reveal. EMR means spinning up clusters just to change a file format. Way too much overhead. B. Glue ETL works but adds a daily job, DPU costs, and a second pipeline to maintain. D. Athena CTAS hits the 100 partition limit on real workloads. It doesn't scale to 5 terabytes per day. That leaves C. Firehose record format conversion. If the data is already flowing through Firehose, you can flip on JSON to Parquet conversion in flight. No second pipeline, no extra compute, and you pay for delivery you'd run anyway. C wins. Question 5. Partners drop files into S3 at unpredictable times. The Glue job should run within seconds of arrival with the lowest operational overhead. A cron scheduled Glue job. B. S3 event notification to event bridge to Glue. C. A Lambda polling S3 every minute. Or D. A step functions polling loop. The qualifier combines 2 things, within seconds and lowest overhead. A cron adds latency and runs even when no file arrived, wrong on both qualifiers. C. Polling Lambda every minute burns money idling and still adds up to a minute of latency. D. A step functions polling loop is an anti-pattern that adds state you don't need. That leaves B. The S3 event notification chain. It's push-based, fires only when a file actually lands, has no idle compute, and is the canonical event-driven ETL trigger on Amazon Web Services. Whenever you see polling on a least overhead question, it's almost always the wrong answer. Question 6. Multiple producers write Avro records to a Kinesis stream. Consumers occasionally break when a producer changes the schema. The team needs automatic compatibility enforcement at produce time. A Glue schema registry. B. Glue data catalog. C. A custom Lambda validator. Or D. A DynamoDB metadata table. The qualifier is automatic compatibility enforcement at produce time. B. The Glue data catalog is for table metadata in your data lake, not streaming payload schemas. Different tool, different job. C. A Lambda validator reinvents a wheel Amazon Web Services already built. D. A DynamoDB table has no compatibility checking logic of its own. That leaves A. Glue schema registry built specifically for streaming payload schemas. It enforces backward and forward compatibility at produce time, and it integrates natively with both Kinesis and MSK producers. The distinction to remember: data catalog is for tables on disk, schema registry is for messages in motion. Question 7, and this one is a classic trap. Lambda consumes a Kinesis stream. IteratorAge keeps rising and records older than retention are starting to expire. Which 2 actions actually fix the lag? A. Add more producers. B. Add shards. C. Increase Lambda batch size only. D. Enable enhanced fanout. Or E. Increase retention from 24 hours to 72 hours. Notice this is a select 2 question. Pause and think carefully, because one wrong instinct here makes the problem worse, not better. A. Add more producers is the famous trap answer. Adding producers makes the problem worse. There's even more data piling up that the consumer can't keep pace with. C. A bigger batch size alone doesn't add any parallelism. E. More retention buys you time before data expires but doesn't actually speed up the consumer. The right pair is B and D. Add shards to enable more parallel consumers and enable enhanced fanout for dedicated throughput per consumer. Picture a conveyor belt at the airport with bags piling up. You don't solve that by sending more bags, you add more lanes and more people grabbing bags. Producers were never the problem. And straight from the Kinesis docs, here's the rule of thumb. IteratorAge should never exceed 50% of your stream retention. When it reaches 100%, data is lost. That 50% threshold is your alarm trigger, not 100. By the time you hit 100%, the records are already gone. Quick recap of what the qualifiers pointed to in Domain 1. Least overhead for validation pointed to glue data quality with DQDL sub-second pointed to Kinesis data streams, never firehose. Minimal code changes for orchestration pointed to MWA, cheapest columnar conversion on a stream pointed to firehose format conversion. And records being lost on Kinesis pointed to adding shards plus enhanced fanout, never more producers. Notice that in every case, the qualifier did the work. The service shortlist was the same, the qualifier picked the winner. On to Domain 2. 5 questions covering storage class selection, Redshift physical design choices like distribution and sort keys, Athena cost optimization, and DynamoDB key design. This domain is where small physical choices have huge cost implications, so the qualifiers tend to be about money and performance. Question 8, and here's another famous trap. A medical imaging firm archives scans that get accessed about once a quarter. When accessed, they must load in milliseconds, no restore wait. Storage cost must be minimized. S3 standard IAB, Glacier flexible retrieval. C, Glacier deep archive, or D, Glacier instant retrieval. The qualifiers are milliseconds and minimized cost. Pause and think, the word Glacier is doing a lot of misdirection here. Milliseconds eliminates the slow Glacier tiers. B, flexible retrieval is minutes to hours out. C, deep archive is 12 hours minimum with no expedited option out. A standard IA technically works in milliseconds, but it's more expensive than needed for quarterly access. That leaves D, Glacier instant retrieval. It delivers in milliseconds with no restore step, and it's cheaper than standard IA for data accessed roughly once per quarter. The brand name lies, Glacier Instant Retrieval is not slow. When a question pairs quarterly or rarer access with millisecond latency, this is your answer. The Amazon Web Services documentation describes Glacier Instant Retrieval as the lowest cost storage for long-lived data accessed once per quarter that requires millisecond retrieval. Notice how tightly that sentence reads. It's almost a literal exam question template. When you see those phrases together in a scenario, the answer is right there in the description. Question 9. A 5-node RA3.4X large Redshift cluster has one node pinned at 90% CPU while the other 4 sit idle. The largest table uses distribution-style key on a status column with 4 distinct values. What's the fix? A. Add nodes. B. Switch to distribution-style all. C. Change the key to the high cardinality customer_ID column. Or D. Switch to distribution-style even. The clue is the cardinality mismatch, 4 distinct values across 5 nodes. Add nodes doesn't fix skew, you just get more idle capacity. B. Distribution style all would replicate the entire fact table to every node and storage explodes. D. Distribution style even fixes the skew but kills any collocated joins on customer_ID that leaves C. Change the distribution key to the high cardinality customer_ID column. 4 distinct status values cannot possibly spread across 5 nodes. At least one node gets nothing. Customer ID distributes evenly and preserves collocation on the column joins actually use. Picture 5 cashiers at a grocery store, but the rule sends every frequent shopper to one cashier's line. Switch the rule to something more varied and the load spreads. Question 10. A Redshift table uses an interleaved sort key across 3 columns. Query performance has degraded and the sort columns need reanalysis. Which maintenance command? A vacuum full, B, vacuum reindex. C, the analyze command, or D, a deep copy operation. The keyword here is interleaved, that one word changes the answer. A vacuum full reclaims space and resorts but skips the sort key column reanalysis that interleaved tables need. C, the analyze command refreshes table statistics, not sort order. D, a deep copy operation is a last resort full rewrite, not the targeted fix. That leaves B, vacuum reindex. It's required specifically for interleaved sort keys because it reanalyzes how values are distributed across the sort columns. It's slower than vacuum full by design. That extra pass is what makes the interleaved sort key keep its zone map advantage. The rule to remember: compound sort key uses vacuum, interleaved uses vacuum reindex. Question 11. Log sit in S3 as gzipped JSON partitioned by year only. Most queries filter by date and event underscore type. What single change saves the most cost? A switch to LZO compression. B, convert to Parquet with date and event type partitions. C, add an Athena workgroup, or D, move to Redshift. The qualifier is most cost savings from a single change. A, LZO compression gives modest savings but doesn't reduce the volume of data scanned. C, an Athena workgroup is a governance and cost cap lever, not a scan reducer. D, moving to Redshift is overkill and adds operational burden you don't need. That leaves B, convert to Parquet with date and event type partitions. Athena charges by bytes scanned. Parquet is columnar, so it skips columns you don't query. Smart partitions skip entire files. Together, real workloads see 90% or more scan reduction. When an Athena question mentions cost, the answer almost always includes Parquet plus the right partitions. Question 12. Base table writes on a DynamoDB table are throttling, but base table capacity is not full. There's a global secondary index, a GSI, with partition key order underscore status, which has 4 distinct values. What's happening and what's the fix? Increase base table WCUB, switch the GSI to on-demand. C, redesign the GSI partition key for higher cardinality. Or D, add DAX. This one tests a subtle pattern. Pause and think about why the base table would throttle when its own capacity isn't full. Increase base table WCU misses the root cause. The base isn't full, the GSI is. B, switch the GSI to on-demand masks the hot partition without actually fixing it. D, add DAX is a read cache. This is a write problem. That leaves C, redesign the GSI partition key for higher cardinality. A 4-value partition key like order status creates a hot partition on the GSI. When that GSI throttles, the back pressure propagates to the base table and it looks like the base itself is throttled. The lesson: when base writes throttle but base capacity is free, suspect the GSI. Recap of Domain 2. Milliseconds plus archive pointed to Glacier Instant Retrieval, not flexible retrieval. Node skew on a Redshift cluster pointed to switching to a high cardinality distribution key. Interleaved sort key maintenance required vacuum reindex, not vacuum full. Athena cost reduction always started with Parquet plus smart partitions. In base table throttling with idle capacity pointed straight at the GSI partition key. Same skill every time. Read the qualifier, eliminate the imposters, choose the survivor. Domain 3. 4 questions on operating and supporting your pipelines, monitoring, troubleshooting, and the cost levers that matter once things are running. These questions tend to give you symptoms and ask you to diagnose. The skill is matching the symptom to the right metric or the right knob. Question 13. Operators need a single CloudWatch metric to alert on Kinesis consumer lag, and the metric must reflect the worst lagging shard, not the average. Incoming records with some statistic. B. Get records.IteratorAge milliseconds with maximum. C. Write provision throughput exceeded with some. Or D. Get records.latency with average. 2 qualifiers to track consumer lag and worst lagging shard. Incoming records is a producer-side metric. It tells you nothing about consumer lag. C. Write provision throughput exceeded is producer throttling, not consumer. D. Get records.latency with average would mask the worst lagging shard exactly when it matters most. That leaves B. IteratorAge milliseconds with maximum. IteratorAge measures how far behind each consumer is per shard, and maximum surfaces the worst lagging one. This is the canonical alarm for records about to expire. The both qualifiers rule: consumer lag eliminates the producer metrics, worst shard eliminates average. Question 14. A daily glue job suddenly reprocesses every file from day 1. The job ran fine for months and nothing in the code changed. Most likely cause: A. An S3 lifecycle policy moved files. B. The job bookmark was disabled or reset. C. The crawler ran twice. Or D. The DPU count was reduced. The symptom, full reprocessing on a previously stable job, points at one specific glue feature. A lifecycle policy would delete or move files. The job would lose data, not reprocess it. C. The crawler affects table metadata in the catalog, not which files the job reads. D. A lower DPU count affects how fast the job runs, not which files it picks up. That leaves B. The job bookmark was disabled or reset. A disabled or reset bookmark means glue reads everything from the beginning. And the dangerous part is that it fails silently, no error, no warning, just a much larger job that finishes successfully. Whenever a stable glue job suddenly reprocesses old data, check the bookmark state first. Question 15. A dev team runs glue jobs against sample data overnight. Job start time isn't critical, only cost is. Lowest risk change to cut glue spend: move jobs to EC2 spot. B. Switch to glue flex execution class. C. Reduce DPS to 2. Or D. Convert to Lambda. The qualifiers are lowest risk and not start time sensitive. A EC2 spot is a classic trap. Glue doesn't run on EC2, it runs on DPS, Amazon Web Services' own billing unit. Spot pricing simply doesn't apply. C. Reduced DPS may break jobs that need parallelism, so it's not low risk. D. Convert to Lambda has a 15-minute limit and isn't built for ETL. That leaves B. Glue Flex Execution class. Flex runs on spare Amazon Web Services capacity at up to 34% off standard DPU pricing. The trade-off is variable start time, which fits perfectly for non-urgent pre-production work. Remember, when you see Glue plus spot in an answer, that's the trap. Glue plus flex is the real lever. Question 16. Application logs land in S3 standard daily. They're queried heavily for 30 days, occasionally for a year, then archived. Your options are A. S3 intelligent tiering. B. A lifecycle policy moving standard to standard IA at 30 days, then to Glacier flexible at 1 year. C. Move everything straight to Glacier deep archive. Or D. Replicate to standard IA. The access pattern here is known and predictable, and that qualifier is doing all the work. Intelligent tiering charges a per-object monitoring fee for pattern detection you don't need. The pattern is already known. C. Straight to deep archive breaks the heavy 30-day query phase. D. Replication adds storage cost rather than reducing it. That leaves B. The lifecycle policy. A known schedule means lifecycle rules win because each tier matches a stage of the data's life. The decision rule to memorize. Known access pattern means lifecycle policy. Unknown or changing pattern means intelligent tiering. Those two phrases divide the entire S3 cost optimization space. This one's worth committing to memory because it shows up in many forms. Known schedule means lifecycle policy. Unknown pattern means intelligent tiering. Anytime an S3 cost question describes a clear timeline, 30 days, 1 year archived, that's a lifecycle question. Anytime it says unpredictable access or unknown pattern, that's intelligent tiering. Recap of Domain 3. Consumer lag on Kinesis points to IteratorAge with the maximum statistic. Glue suddenly reprocessing everything points to a disabled or reset bookmark. Non-urgent glue jobs save money with Flex, not Spot, because DPS aren't EC2. And a known access pattern means a lifecycle policy beats intelligent tiering. Notice that operational questions are mostly about pattern recognition. Match the symptom to the right knob. Domain 4, the final block. 4 questions on security and governance, lake formation for fine-grained access, KMS and VPC endpoints for private networking, PII handling and encryption configuration. The qualifiers here often hide compliance constraints that disqualify otherwise valid answers. Question 17. Finance needs to see full salary, HR needs salary, analytics needs a redacted version. All 3 teams query the same table through both Athena and Redshift Spectrum. What's the lowest overhead governance approach? 3 copies of the table with IAM policies. B. Lake formation column level permissions. C. Bucket policies per team. Or D. Glue data brew masking jobs. The qualifier is lowest overhead, and the shape of the requirement is 1 table, many views. 3 copies of the table means storage duplication and a synchronization nightmare. C. Bucket policies can't operate at the column level, they're file level at best. D. Data brew is a data preparation tool with no access control authority. That leaves B. Lake formation column level permissions. 1 physical table, multiple permission views, enforced on Athena, Redshift Spectrum, and EMR for Apache Spark. 1 caveat worth knowing, Glue ETL jobs do not honor lake formation column filtering, so for analyst access through query engines, this is the right pattern. Think of it like a redacted government document, same page, but each reader sees the version cleared for their clearance level. 1 query, many views. Question 18, and this is the Macie trap. Compliance requires social security numbers to be discovered and masked before analysts query the data. Lowest overhead end-to-end solution? A. Macie alone. B. Macie discovers and Glue data brew masks. C. Glue detect PII alone. Or D. Macie discovers plus manual SQL updates. Pause carefully. The trap here is misunderstanding what Macie actually does. A. Macie alone is the trap. Macie finds PII and classifies it, but it never modifies the data. Choosing A on the exam is one of the most common ways to lose a point in Domain 4. C. Glue detect PII alone can mask, but it doesn't centrally classify across your data lake. D. Manual SQL updates doesn't scale and is error-prone. That leaves B. Macie discovers and data brew masks. Think of Macie as the metal detector at the airport. It finds the dangerous item but doesn't confiscate it. Data brew is the security officer who actually handles it. Discover plus act is the canonical PII pattern. Macie is always part of a pair, never the whole answer. Question 19. Glue jobs in a private subnet must call KMS without traversing the public internet. Which endpoint configuration works? A gateway VPC endpoint for KMS. B. An interface VPC endpoint for KMS with private DNS enabled. C. A NAT gateway. Or D. An internet gateway with a strict security group. The qualifier is that traffic must never leave the Amazon Web Services network. A gateway endpoint for KMS simply doesn't exist. Gateway endpoints only support S3 and DynamoDB. That's the rule worth memorizing. Gateway covers exactly two services. C, a NAT gateway sends traffic out to the public internet. D, an internet gateway has the same problem plus added exposure. That leaves B, an interface VPC endpoint for KMS with private DNS enabled. Private link keeps KMS traffic inside the VPC, and private DNS lets your clients use the normal KMS endpoint name without code changes. Pair it with a KMS key policy that denies access from anywhere except that endpoint, and you've got an end-to-end private path. Question 20, our last one. An EMR cluster processes protected health information. Compliance requires customer-managed key control, and data at rest as well as in transit between nodes must be encrypted. Which configuration? A SSE-S3 only. B, an EMR security configuration with SSE-KMS at rest plus TLS in transit. C, SSE-C with manual key rotation. Or D, client-side encryption only. Two qualifiers, customer-managed keys, and both at rest and in transit. A SSE-S3 uses Amazon Web Services managed keys with no customer control, eliminated by the customer-managed requirement. C, SSE-C pushes all key management onto you operationally, which fails compliance and adds risk. D, client-side encryption only, covers data at rest but misses in-transit encryption between cluster nodes. That leaves B, an EMR security configuration with SSE-KMS at rest using a customer-managed CMK plus TLS for internode traffic. KMS gives you rotation, audit trails, and grants, everything compliance teams ask for. The Q, customer-managed keys, always means KMS with a CMK, never SSE-S3. Recap of Domain 4. Same table with different views per team pointed to lake formation column-level permissions. Discover and mask PII required Macie plus data brew or Macie plus object lambda, never Macie alone. KMS, glue, or Kinesis traffic kept private required an interface endpoint, not gateway. And customer-managed encryption for EMR meant SSE-KMS plus TLS in an EMR security configuration. Look back across all 20 questions and you'll see 3 rules carried every single one. Qualifier first, read the last sentence to find the phrase that does the work. Eliminate before choosing, rule out the imposters before you commit. And when you're stuck between two survivors, default to the most Amazon Web Services native option with the lowest operational overhead. Those 3 rules are your method on exam day. 6 things to carry with you into the exam room. Read the last line first, the qualifier lives there. Eliminate 2 options and your odds jump from 25% to 50%, that's free math. Macie finds. Data brew and object lambda act. Glacier Instant Retrieval is milliseconds, the brand name lies. For rising IteratorAge, add shards or enhanced fanout, never more producers. And known access pattern means lifecycle. Unknown means intelligent tiering. You've now got both the method and the most missed patterns. Good luck out there. And that's a wrap on Practice Exam Walkthrough, 20 scenario questions with deep analysis. If this helped, subscribe for the rest of the Amazon Web Services Certified Data Engineer Associate series. It helps me keep making these lessons free, and I'll see you in the next